This video is going to do one of two things. It's either going to blow your mind or it's really going to piss you off. Either way, I think you're going to get a lot out of this video, and it's going to help you make way better decisions when you mix or master your music. My name is Bobby Balo, and I'm the mixing and mastering engineer at Raytown Productions, which is an online mixing and mastering studio. I also run a Facebook community called the Home Studio Fast Track. It's a great place to go to learn with others and level up your audio skills. So you may have noticed I look a little different today. I'm wearing a lab coat, and that's because I'm a scientist by training, and my mixing and mastering style incorporates the scientific method. So yup, this video is going to get a little nerdy today, but stick with me to the end because I cover some very, very important things. There's a lot of buzz going around right now about clipping plugins in the metal community, and I think most of this is all fueled from the release of a new plugin by Submission Audio called Flatline. There were lots of amazing reviews about this plugin, and some people even claimed it could replace converters that cost more than $10,000. $10,000! And I don't know about you, but I like $10,000, so I wanted to shoot out this plugin against some of the other clippers I use in my normal workflow. So when people talk about clipping their converters, this is a hard clipping process. So in this video, we're going to set all the different clippers up in hard clipping mode. And what I discovered is that 4 different companies actually use the same clipping algorithm. And not just like the same, it's literally the exact same algorithm. And what's crazier is that of the 4 companies, the price of these plugins range from 2 of them being completely free, 1 of them being $49, and the other one being $129. And in this video, I'm going to support these wild, outrageous claims of mine with scientific evidence. And as a gift for you guys, I'm including a free download link. You can get that in the description of all the test files that I have in this video so you can listen to the differences in your home studio. So you may be asking yourself, how is it possible that 4 companies could all be using the exact same clipping algorithm? Well, despite all the claims and marketing campaigns and user reviews and all that stuff, what it boils down to is we are all governed by the same laws of physics. And these clipping plugins work exactly the same way as all these other plugins we use, where you take an audio signal and you apply a mathematical equation to it. Depending on the equation we use, it gives us a different sound or clipping algorithm. And as it turns out, there are 4 companies that all looked at all the equations and chose the same one. Let's take a look at the test files so I can prove it to you. So in this series of tests, we're going to be using a sine sweep that basically ranges from 20 to 20,000 hertz. I'll be including this sweep in the free download so you can use it to test your plugins. The sweep file sounds like this. It gets pretty painful, actually. I then put each of the different clippers on that test file, and we're doing about 8 dB of gain reduction, and I know that's pretty aggressive, but I wanted to make sure that if there were some really subtle differences between the clippers that we'd be able to hear them. I then exported those files, and then that's what we're looking at in this session. So let's quickly go over how the clippers made this sine sweep sound. So let's start with the first one called FreeClip. That's pretty crazy, right? We almost hear like pitches going up, then coming down, and a bunch of other weird noises. Let's listen to the original again, just so you can hear how much cleaner it was. Switch to FreeClip. Yeah, I mean, so there's a lot of artifacts that are happening. Let's check out Flatline. So again, I mean, we're getting a lot of those artifacts. Here's the original. You don't hear any of that swooshing, right? Okay, so if we go to the next one, it's Boz Digital Labs Little Clipper. Let's hear that. So you get the idea, right? It sounds very similar. And here's the last one, GClip. You know, just right out of the gate, all these clippers sound pretty bad, right? I mean, it sounds like there's aliens attacking a city or something. So all those artifacts and alien tractor beam sounds are caused from a mathematical phenomenon called aliasing. And what aliasing is and how it's formed and all that is way beyond the scope of this video, but a little bit later, we're going to talk about how to reduce that in our music. But first, I want to prove to you that all these plugins use the same hard clipping algorithm. So we can use what's called a null test to determine if there are any differences between two different audio files. And the way to do a null test is to invert the phase 180 degrees of one of the files and then compare it to any other file. If the two waves are perfectly identical and we invert the phase of one, the wave going up on one file will perfectly cancel out the wave going down on the other. And so we should have no sound produced if the files are indeed the exact same. So let's test that out. So I've inverted the phase on Flatline, and if we just verify the phase of all the other ones, they're all standard phase. Okay, so we're not inverting the phase on any of these other samples. Okay. Now, if we solo Flatline, remember this is what it sounded like. Okay, we're getting all those swooshy artifacts from aliasing. Okay, now, if we play, remember this is phase inverted, and we play this other one, it should perfectly null, so we shouldn't hear anything if they're exactly the same. Here we go. Do you hear anything? I don't. And if we look at the meter, it's not even detecting anything. This is a perfect null. The entire way through the whole sine suite, from 20 hertz to 20,000, we're not getting any differences. So Flatline and FreeClip are the same algorithm. Let's check out Flatline and Boz Digital Labs Little Clipper. Here we go. Let's put it in. Silence. Do we see anything in the meters? Nothing. Again, same algorithm. Okay, we're doing about 8 dB of clipping. And let's do GClip, which is also another free clipper. Here we go. Nothing. I don't hear anything. Meter shows nothing. It's still playing. If I unmute one of them, there's GClip. And then together they're perfectly null. So what does this mean for us? You can use any one of these 4 companies and you're going to get the exact same sound. And 2 of them are free, so you can save some money there. So I know there's some people right now that are being critical about this observation. And some of you might be thinking, yeah, well, that's cool that you showed it cancel a sine sweep, but in a song, that's way more dynamic. And surely these plugins must act differently when we have complex material like a song. Well, I'm afraid to say that's not really how math works. And again, I'll show you. So let's pull up test samples that I also did using a song. And this song is by a band that I mastered called Funeral Singer. Be sure to check out their music, support them if you like what you hear here. With this song, I did exactly the same processing that we saw for the sine sweep files. All the clippers are set up to be in the hardest clipping mode that they have. The only difference is that in this song, we're seeing about 6 dB of gain reduction. And again, that is just because this is complex material and it's not just a sine sweep. All right, so I'll just play a short snippet of the song as is before we do any clipping. Here we go. All right, so you can hear it's dynamic. there's a lot of stuff going on, right? There's a lot of saturation. It's metal, man. This is a banging song. So let's quickly run through the plugins and do a null test to see if they're the same or not. Okay, so first up is FreeClip. Here's the original. Sounds pretty transparent, pretty good. Let's listen to GClip, which is also free. Okay, sounds similar. Boz Digital Labs little clipper. And finally, let's listen to Flatline. Let's do the null test, shall we? All right, so first up, we're going to take Flatline and invert it again. So we're going to invert the phase 180 degrees, and we're going to compare it to the different clipping algorithms. Here we go. And let's add in FreeClip. Uh-oh, we got a perfect null. I don't hear anything. Do you guys? Let's try GClip. Nothing. Take a look. Short-term integrated. Nothing. Finally, let's listen to Boz little clipper. Nothing. Again, it doesn't matter what the signal is that we're driving into these clippers. We're still doing the same mathematical equation onto the audio signal. So we'll get the same end result. Math is math. You can't change that. So don't let the marketing fool you. We need to talk a little bit more about aliasing because this isn't the complete story with these plugins. You need to be well aware of something else. Remember those harsh artifacts that we heard when we did the Sine sweeps that sounded like aliens taking over the world? That was aliasing. Okay, it doesn't sound pleasant, and typically in mixing and mastering, we want to avoid those as much as possible. And those artifacts are caused basically due to a sampling error. And this is a mathematically predictable thing. It's not like some black magic. In digital signal processing, the way we can get rid of all that stuff is by applying what's called an anti-aliasing filter, which is a really fancy way of saying a low-pass filter. And what that does is it basically just filters out all that high crap so we don't have to hear it. So how do we get rid of the aliasing in our music when we're using plugins like clippers or distortion or whatever? The simple answer is basically you want to use a higher sample rate session, like 48K or 96K. But the problem with using those higher sample rates is it's a lot more CPU intensive, right? So it's harder to run a session that way. So smart plugin companies have developed something called oversampling, which changes the sample rate, and instead of over the whole session, it's confined to just the plugin. And that allows the developers to design and use better anti-aliasing filters that are more transparent and can get rid of more of that crap. It is a little bit more CPU intensive, but it's way less than if we had the whole session running at a high sample rate. So I'll take what I can get. Each of these plugins, except for the Boz Digital Labs little clipper, have some sort of oversampling integrated into the plugins. And that's actually where these are all different from each other. Implementing a good anti-aliasing filter is tricky, and there's a lot more parameters to choose from. So this is where we're going to start hearing some subtle differences between the different plugins. So let's jump back in the session, see if the audio files still null with each other if we're running these plugins with oversampling. Like I mentioned, Boz little clipper doesn't have oversampling, so we're not going to include it. So let's start with FreeClip with 4x oversampling. Let's listen to see how that sounds. And in theory, it should sound better because we should have less aliasing. We can still hear all those swooshing sounds, right? But it does sound like it's improved a little bit. Okay, let's listen to Flatline. Again, it does sound like it might be a little bit improved. And then GClip, the max we can do is 2 times oversampling. So let's listen to that. And actually, GClip doesn't sound like it was really improved much at all with the oversampling. All right, so let's try the null test. So we'll take Flatline, we'll invert the phase 180 degrees, and we're going to see if they cancel out. So let's compare it to FreeClip. Here we go. So they don't perfectly cancel. And if we look at the short term, we're looking at like -18, -20 dB. So the differences between these two oversampling algorithms is around -20 dB. So they might be subtle enough that we may or may not hear them in a really dense metal mix. Okay, but there are differences now. Let's check out GClip. Wow, so these are way different. Yeah, I mean, it's almost as if they're not nulling at all anymore. So there's something going on with the oversampling on GClip that is very different from Flatline. And unfortunately, given the nature of a null test, we don't know which one sounds better or worse. We can only determine if they are exactly the same or not. So one advantage to FreeClip is that they actually have a 32 times oversampling feature. So in theory, this should give us the cleanest results. So let's see if Flatline at 4x will null with the 32x of FreeClip. So they get pretty noticeable there. But in the beginning, there's barely any difference. I would argue that's almost inaudible in a dense metal mix. So cool, there are some subtle differences when we oversample the plugins, but how do we know which one is the best, right? And I have two suggestions for this problem. Well, the first and most important thing that we can do to decide what's best is to use our ears. I know, controversial, right? Use your ears. But we need to be very, very aware that we are human beings and we're very susceptible to bias and preconceived ideas we have surrounding these companies based on their marketing tactics, their testimonials, the graphical interfaces we use. So minimize those distractions and make sure you do a blind listening test, because without these null tests, a lot of people would never know that they're using the exact same algorithm without any oversampling. And again, as a reminder, I have these files available for download so you can listen and do your own testing at your studio. If it's really hard to tell between the different clipping algorithms, the differences just might be too small to detect in a home studio environment, which also means that it doesn't really matter a lot to anybody else either. So stop worrying about these stupid clipping plugins and just make some music. So the second thing we can do, which is a lot more scientific and more my kind of thing, is to analyze the data and see which one mathematically or scientifically provides the least amount of artifacts to the audio. In this way, this gives us at least some sort of objective data to use when we can't make up our minds. So we can use a free program called Sonic Visualizer to generate a spectrogram, which we can then use to analyze the aliasing artifacts that we see. Here's Sonic Visualizer. So to generate a spectrogram, import a WAV file or whatever file you want. Okay, so we're just going to load the sweep file. We're going to right-click on it, go to Layer, and Add Spectrogram. Here is a spectrogram. So to understand what a spectrogram looks like, let's start with like a typical meter that you see usually when you EQ. So I'm just going to play the sine sweep. Okay, so that's just like if you're EQing, right? We see frequency and then how the amount of level at that frequency. So this is a spectrogram down here. It's basically the same thing. It's this figure, just with this tipped on its side. So the frequency is plotted on the y-axis, and then time is on the x-axis. So basically what we're looking at is this plot plotted in real time. And instead of us just knowing the number of the amplitude of the sound file, we get a color in a spectrogram. So the more red it is, the louder the signal is, and the more blue it is, the quieter it is. So let's take a look at what they look like. Okay, so we're looking at the frequencies getting higher and higher in pitch with time. So it's just this straight line here. It's as simple as that. So this is how I generate all the spectrograms that we're going to be seeing in a second. This is that sine sweep, and the only signals we see in the audio are along this line. So I've gone ahead and generated all the different spectrograms for those sine sweeps with the clipping plugins at different oversampling rates, so we can try to visually see which ones are generating the least amount of artifacts. Before I tell you which plots are which plugins and at which oversampling rates, let's just look at these spectrograms and see if we can identify some that look different from the others. So every plot is going to have this diagonal line running through it, and every other line we see is some sort of artifact from the clipping plugin. The way these are set up right now with this color scheme makes it a little bit difficult to see the differences. Now I'm going to change some of the culling parameters just to make it easier to see the differences between the different plugins. We can see that this one seems to have a lot of these aliasing artifacts. These two seem to be better. We scroll down here and look at some more. These, the majority of these four all look about the same. And I would say this one looks cleaner than any of these four. This first one is actually FreeClip without any oversampling. This one here, which we can tell is clearly better than almost any of these other ones, right, is FreeClip at 4x oversampling. And then this one, which looks the best out of all of them to me, this is FreeClip again at 32x oversampling. So the free plugin, the free clipping plugin, is the best in terms of aliasing. It has the least amount of artifacts. It's the most transparent to our audio source. So the next one is Flatline without any oversampling. We can see there's a ton of artifacts, right? In fact, it's exactly the same amount of artifacts as this one because we did the Null test to prove that. This one is Flatline with 4x oversampling. And for whatever reason, this filter design for the anti-aliasing didn't seem to be as good as FreeClip, right? If we compare this and this, FreeClip does a much better job of reducing those artifacts. This is Boz Digital Labs' little clipper. Okay, again, looks identical to that because it is. And finally, these last two are from GClip, another free clipping plugin. So even though we heard a lot of differences, the artifacts that we're seeing from the 2x oversampling seem to be reduced. If you look closely, you can see that bright red line here. And in almost all the other samples that we're looking at, it's a dark red line. That means that we're actually getting louder aliasing artifacts that are going to be more audible in these higher frequencies here, but the number of overall artifacts is reduced. It actually might be more noticeable than if you were just to use the non-oversampled version of the plugin, which is kind of crazy to think that. So don't always think because it has oversampling, it means it sounds better. Make sure you're using your ears first. So if we can't really tell a difference when we have the plugins in our session, you can use this spectrogram data to know which ones are going to be generating the least amount of artifacts for your song. So in this case, if we were to rank these, clearly FreeClip is the best in terms of the artifacts that are generated, followed by either Flatline at 4x oversampling or perhaps maybe GClip at 2x. So given all the data I've shown you today, plugin that has the least amount of artifacts with oversampling is clearly FreeClip. And given that FreeClip is, like its name implies, free, I'm going to be reaching for that over Flatline pretty much any time I need to use clipping. But let your ears be the judge and make sure you do the tests. All right, that was a lot of stuff in this video. So let's recap some of the main takeaways that we talked about today. Number one, understand that we are all human beings and we are very susceptible to bias, especially when it comes to mixing and mastering audio. We need to minimize these biases using test audio files and blind listening tests to really figure out what sounds best for our music. Number two, do not buy into marketing hype of plugin companies without doing your due diligence first in performing these kinds of tests. We're all bound by the same laws of physics, and I just showed you in this video that for these companies, all use the same code in their plugin. But that being said, be absolutely sure that you always use your ears. Making music is an art after all. And your clients probably aren't going to be looking at spectrograms of their music, so you're safe there. So number three, Make sure to experiment often. Download those test files that I've prepared for you to test what your plugins are doing under the hood. And if you want to dive deep into what the plugins are actually doing, there's a really, really awesome tool called Plugin Doctor by DDMF. And I have a link to that software in the description. It's not that expensive, and it really will give you a lot of insight into what your plugins really are doing under the hood. Number 4, make sure to trust your ears. And I don't think I need to talk about that anymore. Finally, number 5, you made it this far, be sure to hit that like button and tell YouTube that this video was helpful. And if you know a friend that might be interested in learning more about this stuff, share this video with them. I spent a lot of time putting the best information together in these videos, and it would absolutely mean the world to me if you would hit that subscribe button so you don't miss a single video when I release them every single week. Let me know what your thoughts are in the comments below. And just like any good science conference, the discussion that typically follows the talks is where we learn the most. And remember, I am human, so if I made a mistake, be sure to kindly point that out in the comments as well. Thank you so much for your time today, and as always, I'll see you in the next video.